Chapter 1. Sources of Food. Introduction. All living things need energy to live and grow. They get energy from the food they eat to perform day-to-day activities. Functions of food. Food provides us energy to work, to grow, and to keep us healthy. Sources of food. There are two main sources of food. Number 1, plants. Number 2, animals. Food from plants. Green plants prepare their own food by the process called photosynthesis. Plants give us food in the form of vegetables, fruits, cereals, pulses, sugar, oils, and spices. Vegetables. Potato, onion, radish, carrot, tomato, etc. are some common vegetables. They give us vitamins, minerals, and roughage. Fruits. Mango, banana, apple, grapes, etc. are some common fruits. They also give us vitamins, minerals, and roughage. Cereals. They are main source of food. Wheat, rice, bajra are the main cereals. They provide energy. Pulses. Pea, gram, bean, etc. are common pulses. They provide proteins to grow. Oils. Some seeds of plants provide oils when crushed. Common oil-producing plants are mustard, groundnut, soya bean, etc. Spices. Different parts of plants are used as spices. Ginger, coriander, cumin, fenugreek are some common spices. They provide flavor to the food. Sugar. We get sugar from sugarcane and sugar beet. It gives us energy. Food from animals. Animals give us food in the form of milk, meat, eggs, fish, and honey. Milk. Milk is considered as a complete food. Cows, buffaloes, and goats are the main milk-yielding animals. Meat. It is rich in proteins. Goat, sheep, hen, and duck are common animals used for meat. Eggs. Birds provide both meat and eggs. Chicken, fowl, and duck provide meat and eggs. Fish. It is also a major source of food. It is rich in proteins and is easily digestible. Katla, labio, rohu, etc. are some common fish. Rearing of fish on a large scale is called pisciculture. Food product from insects. Some insects like honeybee give us honey. It contains water, sugar, minerals, and enzymes. It also has medicinal values. Food habits of animals. Animals cannot prepare their own food. They are called heterotrophs. This means they depend on plants for food directly or indirectly. Different animals eat different food. On the basis of feeding habit, animals are divided into following groups. Herbivores. Animals that eat plants on their products, buffaloes, cows, horses, etc. are herbivorous. Carnivorous. Animals that eat flesh of other animals are called carnivores. Lions, tigers, wolves, and vultures are carnivorous. Omnivorous. Animals that eat plants and other animals are called omnivorous. Some omnivores like cows, jackals are called scavengers. They consume dead bodies of animals and keep environment clean. Parasites. Small animals that depend on other living animals for their food are called parasites. Some parasites are tapeworm, roundworm, and hookworms. Cooking of food. Except fruits and some vegetables, humans cannot consume food items as such. It has to be cooked. Cooking makes food eatable, digestible, tastier, and germ-free. However, overcooking should be avoided, else vitamins and minerals of the food would be spoiled or lost. Food habits of people of different regions of India. In different parts of the country, people generally consume 2 or 3 meals depending on the income. Some are Eastern region. In this region, they mainly eat rice and fish. Bihar, West Bengal, Odisha, and Assam are Eastern region. Western region. In Gujarat, Maharashtra, and Goa, People also eat fish and rice mainly. They also consume dhokla, pulses, and groundnut products. Northern region. People of Punjab, Rajasthan, Haryana, and Himachal Pradesh eat chapati, parathas, and pulses. Southern region. People of this region consume mainly sea animals, fish, and rice. They also eat idli, dosa, sambar, etc. Keywords: organism, all. Chapter 2: Components of food. Introduction. Food is the basic necessity of life. No single food is perfect that can supply all the nutrients needed for us. So, we have to eat different kinds of food items to get all the nutrients. Types of food. Food can be classified as: number 1, energy-giving food. Sugar, cereals, jaggery, oils, potato are some energy-giving food. Number 2, body-building food. Milk, pulses, meat, egg, etc. are called body-building food. Number 3, protective food. Milk, green leafy vegetables and fruits are called protective food as they protect us from diseases. Components of food. The human body needs 5 types of nutrients. These include carbohydrates, fats, proteins, vitamins, and minerals. Carbohydrates for energy. Starch and sugar are called carbohydrates. Rice, wheat, maize, potatoes, bananas, and sugarcane provide starch or sugar. Carbohydrates are of 3 types. Number 1, sugar. 2, starch. 3, cellulose. Sugar is present in all fruits. Milk, sugarcane, and honey also give sugar. Starch is present in potato, rice, wheat, etc. Cereals also provide starch. Cellulose is present in the fibrous parts of fruits and vegetables. Cellulose is responsible for proper bowel movement. Fats provide energy and warmth. Plants like groundnut, coconut provide fat. Milk products as ghee, butter, and eggs, fish, etc. provide fat. Did you know? A good way to know if an egg is rotten is to put it in water. If it floods, it is likely to be rotten. Bacteria that spoil the egg enter through the pores in the shell and create a gas that causes the egg to flood. Proteins for growth and repair. Proteins help the body to grow or repair the damaged and worn out tissues of the body. They also form muscles, hair, and nails. Children need more proteins. Deficiency of proteins can cause diseases. Proteins by animals like milk, cheese, egg, fish, meat, and by vegetables like pulses, soya beans, nuts, etc. Vitamins for health. Vitamins are essential for growth and health. However, in small quantities. Human body needs vitamins A, B, C, D, E, and K. Vitamin A and B complex are water soluble and vitamin A, D, E, K are fat soluble. Milk, fruits, vegetables, meat, and eggs are some sources of vitamins. Lack of vitamins causes deficiency diseases. Common vitamins, their functions, and the foods they can be obtained from. Vitamin A. Functions: keeps eyes and skin healthy, helps fight infection. Food sources: carrot, spinach, pumpkin, ripe mango, sweet potato, tomato, papaya, liver, eggs, fish, butter. Vitamin B complex. Functions: keeps muscles, brain, and nerves healthy. Food sources: whole grain, kidney bean or rajma, nuts, gram, beans, spinach, peas, soya bean, meat, liver, eggs, fish, butter, milk, curd. Vitamin C. Functions: keeps gums and skin healthy, helps heal cuts. Food sources: fresh lemon, orange, sweet lime, tomato, melon, spinach. Vitamin. Vitamin D functions, makes bones and teeth strong and healthy. Food sources: milk, fish liver oil, cod, sardine, salmon. Minerals. Chapter 3: Cleaning of Food. Introduction. We should eat clean food free from all undesired substances. Harmful or non-useful substance may be fixed with the food. They have to be separated. A large variety of materials are found on the earth. These materials can be classified as pure substances and mixtures. Pure substances. A substance made up of only one kind of molecules or atoms is called a pure substance. Pure substance has a definite composition, homogeneous in nature, and has a definite melting point (MP), boiling point (BP), and density. All elements such as gold, silver, copper, oxygen, hydrogen, etc. are pure substances. Mixture. A mixture contains two or more kinds of particles of different substances which can be separated by physical means. Mixtures are of two types: A. Homogeneous, B. Heterogeneous. A. Homogeneous mixtures. The mixture which has the same composition throughout is known as homogeneous mixture. Example: salt dissolved in water. B. Heterogeneous mixtures. The mixture which does not possess uniform composition is known as heterogeneous mixture. Example: iron fillings mixed with sulfur powder. Properties of mixtures. In a mixture, components can be mixed in any ratio and can be separated by simple methods. Table of differences between pure substance and mixtures. Pure substances. Number 1. Pure substances consist of particles of one kind only. Mixtures. Number 1. Mixture consists of two or more type of particles. Number 2. Pure substances. Pure substances are homogeneous. Mixtures. Number 2. Mixtures are homogeneous as well as heterogeneous. Number 3. Pure substances. Pure substances have definite melting point, boiling point, and density. For example, melting point of ice is equal to 0 degrees centigrade and boiling point of water is equal to 100 degrees centigrade. Number 3. Mixtures. A mixture has no definite boiling point and melting point. Mixtures, they change as per the change in the constituent particles. Some examples of mixtures. Number 1. Seawater is a mixture of several salts. 2. Air is a mixture of many gases. 3. Smoke is a mixture of carbon particles and air. Why is the separation of mixtures necessary? No substance in nature is 100% pure. Impure food, if consumed, can cause serious diseases. For example, arhar dal grows with kesari dal. The kesari dal causes paralysis if consumed. So, before using any substance for human and animal consumption, its harmful components need to be removed. Removal of certain components of a mixture is called separation of mixture. It is done for the following purposes: removing undesirable components. Small stones, if present in pearls and rice, clay or sand in water, have to be removed before consuming. Removing harmful components. Seawater is harmful to health. Salt is to be removed from the seawater to make water fit for drinking. Obtaining useful component. Various useful components like petrol, diesel, kerosene, natural gas is separated from crude petroleum. These components are used for various purposes. Obtaining pure substances. Pure substances are needed for various purposes. For example, pure gold is needed for making ornaments. Cleaning of food. Food is cleaned to prevent it from spoilage due to microbes, to make it nutritive, to improve its quality, and to make it tasty. Did you know the process of deliberately mixing food materials with cheap, unwanted, harmful things is called food adulteration? It leads to many health hazards. Post-harvest practices used by farmers to obtain grains from the plants. Number 1. Threshing. The harvested crop is threshed to separate the grain from the chaff. Small farmers beat the harvested crop with sticks or tread the crop with animals for threshing. However, in case of big fields, motorized threshers are used for threshing. This method is economical and time-saving. Number 2. Winnowing. In this method, threshed crop is made to fall from a height. Grains being heavier fall vertically down and the husk being lighter are carried away by the wind. Number 3. Hand picking. Small pebbles, dust, dirt, etc. are separated by this method from a mixture. A housewife separates small stones from pulses by hand picking. Number 4. Sieving. This method is used to separate particles of different sizes in a mixture. For example, your mother sieves wheat flour at home. Techniques used for separating mixtures: separation of insoluble solids from liquids, sedimentation and decantation. In a mixture of liquid and an insoluble solid, it is allowed to stand for some time undisturbed. Solid settles down. This is known as sedimentation. Removal of clear liquid layer is called decantation. Coagulation or loading. Sometimes the insoluble solid in a liquid does not settle down. To do this, some coagulant, commonly alum or fitkery, is added. This settles the impurity and the process is called coagulation or loading. Filtration. Filtration is used to remove fine insoluble solid particles in a liquid. Filter paper is used to do this. It has very fine holes in it. The liquid can pass through the holes, but the solids are retained on the top. The liquid that passes through the filter paper is called filtrate. The solids retained are called residue. City water works. Water we use should be properly clean. Unclean water can cause diseases. City water works cleans the water we use. This process includes sedimentation and decantation, loading, filtration, and chlorination. In chlorination, chlorine is added to water to kill germs. Water filters. Nowadays, water filters are being commonly used in homes. These filters remove suspended particles, bacteria, virus, etc. if still present in water supplied by city water works. This water is safe for consuming as it is free from disease-causing microbes. Separation of soluble solids from liquids. Evaporation. Mixture of a soluble in liquid is separated by this method. Mixture is heated, liquid evaporates and solid remains. Salt separated from seawater by this method. Churning or centrifugation. Very fine or suspended particles of solids in a liquid are separated by this method. It is done by rotating the mixture at a very high speed. This method is being used nowadays in dairies to separate cream from milk. Churning is also used to separate butter from curd. Distillation. It is the process by which we can separate a pure liquid from a solution, which may contain dissolved solids. Solution is heated, vapors are cooled, condensed vapors from liquid again, and impurities are left behind. Water obtained by this method is called distilled water and the process is called distillation. Separation. Using more than one method. Number 1. Removal of iron fillings. By a magnet, iron fillings are removed first. Number 2. Removal of sand. Remaining mixture is dissolved in water. Salt will dissolve by filtering. Insoluble sand will remain on filter paper. Number 3. Obtaining common salt from the filtrate. By boiling the filtrate, water will evaporate and the salt will remain behind. Chapter 4. Fiber to fabric. Introduction. Food, shelter, and clothing are the basic needs of each human being. Early man used animal skin, plants, leaves as clothing. Modern man uses all sorts of clothing depending upon weather and occasion. Some professionals wear clothes that shows who they are and what they do. Their clothes are called uniforms. Clothes can tell the history of a man. The history of clothing. Early man covered his body with animal skin and leaves of plants. Later he discovered fibers. He learned to weave these fibers and produce cloth or fabric. Until the invention of stitching needle, he wrapped the cloth around his body. Then he started stitching the clothes. Later machines were invented to spin, weave and stitch clothes. Early Indians used cotton fiber to produce clothes. People wear clothes according to the weather, occasion, and their status nowadays. Some dresses indicate the state or country of the wearer. Different types of clothing materials are available at present, that is, cotton, wool, silk, and synthetics. Classification of fiber. In ancient times, there were only a few natural fibers, namely animal, vegetable, and mineral. The modern fiber classification can be done as natural and man-made fibers, synthetic fibers, textile fibers, natural fibers, vegetable, cellulose, animal protein, mineral, animal protein, wool, silk, vegetable, cellulose, stem, bast, jute, ramie, flax, hemp, kenaf, leaf, sisal, seed, cotton, fruit, coir. Man-made fibers, natural polymer, regenerated, synthetic polymer, polyester, nylon. Other man-made fibers, synthetic, natural polymer, regenerated, rayon, cellulose, natural rubber. Types of cloth material. Cotton, wool, silk, and synthetic fibers are the four main materials for making clothes today. Cotton, wool, and silk are natural fibers, while synthetic fibers are made mainly from petroleum. Development of synthetic fibers. Synthetic fibers were invented in late 1800. There are two types of synthetic fabrics: cellulose-based like rayon and acetate fabrics, and the other petroleum-based like Kevlar, nylon, polyester, acrylic, polypropylene, etc. All fibers, natural and synthetic, are made from natural resources. Some resources are renewable as they are replenished by natural cycles. Fibers from trees, plants, and animals are renewable. Some sources are non-renewable like polyester, toluene, nylon, polypropylene, which are made from oil and petroleum. Man-made fibers. Common name: rayon. Uses: area rugs, substitute for cotton in clothing, disposable non-woven fabrics and paper. Acetate, suit linings and cigarette filters. Nylon, hosiery, lingerie, sport garments, soft-sided luggage, upholstery, tires, ropes, seatbelt, parachutes, fishing lines, nets, and hoses. Kevlar, Twaron, Technora, radial tire belts, bulletproof vests, reinforcement for boat hulls and aircraft panels. Stretch fabrics, example for sportswear and swimsuits. Advantages and disadvantages of natural fibers. Advantages: these fabrics retain body heat, absorb sweat, and are comfortable to wear. Disadvantages: they do not retain crease for long, shrink after washing, and are attacked by moths and molds. Advantages and disadvantages of synthetic fibers. Advantages: these fabrics wash easily, crease resistant, and not attacked by moths and molds. Disadvantages: they do not absorb sweat well, not suitable to wear in summer, and can catch fire easily. Some fibers and their sources. Cotton and mango have fibers on their seed. Coconut has fiber on its fruit. Banana plant has fiber on its leaf. Fibers obtained from animals include hair, fur, wool, and silk. Cotton. It is a very soft fiber that grows around the seeds of the cotton plant. The process of separating fiber from the seed is called ginning. Fiber is then spun to make thread, which by weaving produce cloth. Cotton clothes are comfortable to wear. Cotton crop needs black soil or alluvial soil for rich growth. Flax. Common flax is a natural cellulose fiber, also known as linseed. It is oldest fiber crop in the world. Flax fiber is soft, lustrous and flexible. High quality paper is produced with flax, which is used to print currency notes and cigarette paper. Jute. It is rainy season crop. Almost 85% of jute is produced in Ganges Delta in India and Bangladesh. Jute have more than 1,000 uses. It is said jute is chiefly used to make cloth for wrapping cotton bales, sacks for keeping grain. Coir. Coir is obtained from coconut fruit cover. It has good abrasion, water and weather resistance. Indoor and outdoor mats, rugs and floor tiles are also made of coir. Plant sauces. Kapok. It is obtained from the seed of the kapok tree of Caribbean forest. Animal sauces. Some animals provide natural fibers for cloth, that is, wool from sheep, Illama cashmere from Kashmiri goats, silk from silkworm, fur from the mink, beaver. Leather is also widely used as fabric. However, it is not a fiber. There are two important fibers used for clothing. Wool. Wool is derived from the hair of sheep and some other animals. By shearing, we take hair of sheep. Wool is fluffy and is a bad conductor of heat. Wool clothings are used in cold weather. Did you know? Angora, cashmere, mink are some other animal fibers obtained from fur of goat or rabbit. Did you know? Many places in India are famous for their handloom saris. These differ from one another in the pattern of weaving and their designs. Kanjivarang silk is one such type of fabric. Silk. Silk is obtained from an insect called silkworm. It feeds itself on mulberry trees. The caterpillar of silkworm spins a cocoon around itself and changes into pupa. Cocoon is boiled in hot water. Silk strands so obtained are spun into a reel. Production of silk from a silkworm is called sericulture. In ancient times, its trade was so extensive that route between Europe and Asia was known as the Silk Route. Did you know? Shahtush is a fabric made from fiber obtained from a type of deer. It has now been banned because it involved cruelty to the deer. How fabrics are made? By spinning fibers from yarns. During independence movement, Takle and Charkha were used to produce homespun yarns of cotton for clothing. This clothing was named Khaddar. By weaving and knitting, fabric are made from yarns. Weaving. In this process, two sets of yarns are arranged together to make a fabric. Loom is a machine used for weaving. Loom may be hand loom, run manually, or power loom, run by machines. Netting. It is done either by hand or by machines. Yarns or threads are twisted to produce cloth. Activity. To find the water absorption capacity of different fibers. Chapter 5. Grouping of materials. Introduction. Objects and materials can be grouped together on the basis of similarities and differences in their properties. It helps us to locate a particular object with ease and convenience. Due to this grouping of materials, grocer can give you required item easily. Similarly, a librarian can issue you the desired book. Materials around us. Material is the matter from which something can be made. Objects around us are made of several material like wood, nail or iron, plastic, leather and steel, etc. Materials occurring in nature are called naturally occurring materials like cotton, wood, silk, cereals, fruits, etc. Materials which do not occur in nature but are made by man are called man-made materials like plastic, glass, nylon, steel, soaps, etc. Grouping of materials. Materials can be grouped on the basis of properties such as luster, solubility in water, hardness, conduction, density, transparency, magnetic properties, etc. The process of grouping things according to some common properties is called classification. Classification is done on the basis of some similarities and dissimilarities. Physical properties of materials. Appearance or luster. The materials which have a special shine on them are said to be lustrous, and the special shine on them is called luster. For example, gold jewelry, new bicycle handle shine. Generally, metals have luster. Metals lose their luster when exposed to air. Mercury, a liquid metal, is also lustrous. No gas has luster. Hardness. When the surfaces of two different materials are rubbed against each other, the surface which scratches the other surface is said to be hard, and the property is called hardness. Diamond is the hardest material known. Glass is next to diamond in hardness. Soapstone is the softest substance. Solubility in water. Certain substances dissolve completely in water. They are called soluble substances, and this property is called solubility. If a substance does not dissolve in water, it is called insoluble substance. Water is universal solvent. Solubility of some substances in water. Number 1. Solids. A large number of solids are insoluble in water. For example, metals, stones, wood, etc. But solids like sugar, common salt are soluble. Number 2. Liquids. Most of the liquids are soluble in water. They are called miscible liquids. For example, alcohol, vinegar, lemon juice, etc. Oils are insoluble in water. These are called immiscible liquids. Number 3. Gases. Most of the gases are insoluble in water. For example, nitrogen, hydrogen, and carbon monoxide are insoluble. Oxygen is partially soluble. Did you know? The gas cylinder which we use in our kitchens is filled with LPG, liquefied petroleum gas. CNG, compressed natural gas, is used for running scooters, buses, cars, etc. Floating or sinking in water. Substances like common salt, sugar sink in water, whereas oil floats on the surface of water. It is due to their densities, heavier than water will sink and the lighter will float. Transparency. If one is able to see easily through a material, the material is said to be transparent, and the property is called transparency. If one is not able to see through a material, it is called opaque, and the property opacity. On the basis of this phenomena, matter can be classified as transparent or opaque. A. Solids. Solids are generally opaque. For example, metals, wood, etc. Some solids like glass and certain plastics are transparent. B. Liquid. Most of pure liquids are transparent. For example, water, alcohol, petrol, etc. C. Gases. All gases are transparent. For example, oxygen, nitrogen, chlorine, etc. However, some materials do not allow light to pass completely. They are called translucent materials. For example, oiled paper, butter paper, ground glass, etc. Conduction of heat. The materials which allow the heat energy to flow through them are called conductors of heat. All metals are good conductors of heat. Silver is the best conductor, followed by copper and aluminium. The materials which do not allow heat to pass through are called bad conductors. Wood, plastics are bad conductors of heat. For this reason, handles of cooking vessels are made of wood or plastic. Most liquids except mercury are bad conductors of heat. Mercury is used in thermometers. All gases including air are bad conductors of heat. A sweater traps air in it, and so in winter it lets you feel warmer. The good and bad conductors of heat. Boil some water in a beaker. Keep a metal spoon and a wooden spoon in this water for about 5 minutes. Feel them after every minute. Do you observe any difference in hotness when you touch them? You will find that the metal spoon becomes hot while the wooden spoon does not. The substances that conduct heat are known as good conductors of heat. Metals such as copper, aluminium, and iron are good conductors of heat, whereas non-metallic materials like plastic, wood, rubber, etc. are bad conductors of heat. Combustibility. The property by which certain substances catch fire when heated in presence of air is called combustibility. Materials which do not catch fire on heating in presence of air are called incombustible substances. Some combustible and incombustible substance among solids, liquids, and gases are A. Solids, dry wood, some gases, coal, charcoal are examples of solids which are combustible. Metals like sodium, potassium are combustible. Non-metals like sulfur and phosphorus are combustible. B. Liquids. Petrol, diesel, kerosene, coconut, and mustard oil, alcohol, etc. are combustible liquids. Water, vinegar, etc. are incombustible. C. Gases. LPG, liquefied petroleum gas, and CNG, compressed natural gas, are highly combustible. They are used for cooking and for driving motorized vehicles. Hydrogen is another combustible gas. Nitrogen is incombustible. Oxygen is not combustible but supports combustion. Attraction towards magnet. Some materials attract towards magnets. They are called magnetic materials. For example, iron, cobalt, and nickel. Materials which are not attracted by magnets are called non-magnetic materials. For example, wood, plastic, wool, etc. Some other properties of materials. Elasticity. If a material retains its original shape after withdrawing the force applied on it is elastic. For example, spring balance. Malleability. The property of substance of being beaten into thin sheets is called malleability. Gold, silver, iron, etc. are malleable, while sulfur, phosphorus are not. Plasticity. The materials which cannot retain their original shapes after withdrawing the force applied on them are plastic substances. For example, clay and dough made from flour. Ductility. Ability of metals being drawn into wires is called ductility. For example, gold, silver, copper, etc. are ductile. Volatility. The property of a liquid to get converted into vapors is called volatility, and the substance is called volatile. Chloroform and water are volatile substances. Chapter 6. Changes around us. Introduction. Everything in this universe undergoes a change. You can notice it anywhere. You yourself are changing every day. Germination of seeds, ripening of fruits, milk turning into curd are some examples of changing. Some changes can be noticed at once, while many changes go unnoticed. Why do changes occur? Weather changes due to the heat of sun. Day and night alternate due to rotation of the earth. Every change has a cause. Change may be in shape, size, color, etc. Classification of changes. Changes can be placed in the following categories. Number 1. Slow and fast changes. 2. Desirable and undesirable changes. 3. Reversible and irreversible changes. 4. Physical and chemical changes. Slow and fast changes. Some changes are very slow. They may take hours, days, months, or years. Growing of a plant from its seedling, ripening of fruits on plants are some examples. Some changes are very fast. They take seconds or minutes. Changing of ice into water and explosion of a cracker, etc. are fast changes. Desirable and undesirable changes. Changes useful to us are desirable, and changes which are not useful or harmful to us are non-desirable. For example, ripening of a mango is desirable, but over-ripening, rooting, is undesirable. Reversible and irreversible changes. Reversible changes. Ice changing into water and this water changing into ice is a reversible change. Water cycle in nature is a reversible change. Water, warm, ice, cool. A metal melts on heating and regains its solid form on cooling. Due to this property, metals can be molded in any form. Irreversible changes. If you boil an egg, it changes into a solid. Milk changed into curd. These changes cannot be reversed. They are called irreversible changes. Physical and chemical changes. Physical changes. When only physical properties of a substance are affected during a change, it is called a physical change. In most cases, physical changes are reversible. Water cycle in nature is a physical change. A physical change can be reversed. It is a temporary change. Chemical changes. Continuous heating of sugar changes it to carbon whose properties are different from the sugar. It turns into a different substance. It is a chemical change. In a chemical change, more than one substance react, called reactants, to form different substances called products. A chemical change may be reversible or irreversible. Hydrogen and oxygen combine to form water is a chemical change. 2H2O plus O2 gives 2H2O. Chemical change is permanent in nature, generally irreversible, and the properties of new substances formed are different from those of the original substances. Differences between physical and chemical changes. Physical changes. Number 1. Most physical changes are temporary and can be reversed. Chemical changes. Number 1. A chemical change is permanent and cannot be reversed easily. Number 2. Physical changes. No new substances are formed. Chemical changes. Number 2. New substances with different properties are formed. Physical changes. Number 3. Energy may not be used or produced. Chemical changes. Number 3. Energy may be used or produced. Ways to bring about physical and chemical changes. There are various methods to carry out physical and chemical changes. Some of them are: Number 1. A gap is left between two rails of railway track. This gap accommodates expansion of rails during hot summer weather without damaging the tracks. Number 2. If very hot liquid is poured in a glass pot, it cracks. The inner surface of pot expands more than the outer surface. Outer surface takes more time to be hot and thus it cracks. Number 3. Both expansion and contraction are involved during the process of fixing the metal rim on the wooden wheel of a cart. Metal rim slightly smaller than the wheel is heated. It expands and fitted into the wheel. On pouring cold water over the rim, it contracts and grips the wheel firmly. Examples of chemical changes. Chemical changes occur due to chemical reactions as number 1. On burning coal, carbon dioxide gas is produced with ash. Composition of coal, ash and carbon dioxide gas are totally different from one another. Number 2. When an electric current is passed through water, it splits into hydrogen and oxygen gases whose properties are different from water. Number 3. Iron articles exposed to moist air start rusting. The properties of rust and iron are totally different. A change involves interactions. In a change, two or more materials influence each other. When you sharpen a pencil with a sharpener, both the blade and the pencil undergo changes. Change in the pencil can be seen immediately, but the change in the blade can be seen only after repeated use when it becomes blunt. A change involves energy. Melting of ice is a change. Heat energy is absorbed by ice to melt. When water is added to lime, chuna, it undergoes a change and produces heat. Thus, energy is involved whenever a change occurs. Knowledge about the amount of energy involved in a reaction helps in controlling it and putting it to proper use. Dissolving is a way of changing things. Number 1. Solute. A substance which dissolves in a liquid is called a solute. Number 2. Solvent. A liquid which dissolves another substance in itself is called a solvent. Water, alcohol, carbon disulfide are some common solvents. Number 3. Solution. A homogeneous mixture obtained by dissolving solute in a solvent is called a solution. When common salt dissolves in water, it forms common salt solution. Sulfur on dissolving in carbon disulfide forms sulfur solution. Number 4. Saturated solution. A solution which cannot dissolve more of a solute at a given temperature is called a saturated solution. For example, when sugar stops dissolving in water at room temperature, then this solution is called saturated solution of sugar at room temperature. 35 gram of common salt dissolving in 100 gram of water forms saturated solution at room temperature. Solubility of a substance increases generally with the increase in temperature. Activity. Chapter 7. Life around us. Introduction. There are many living beings around us like animals, plants, and microorganisms. Similarly, non-living things like rocks, water, and wood are around us. All living and non-living things have different structures and functions. Some living beings are very big and some are very, very small. Small living beings are called microorganisms. To study better, things have been arranged in groups as things, living, animate, non-living, inanimate. Non-living, inanimate, man-made, natural. Classification of things. Common features of living and non-living things. Life around us is made up of structural units. Structural unit of non-living thing is the molecule, while that of living thing is the cell. Cells vary in size and shape. Differences between living and non-living things. All living things have special characteristics like growth, intake of food, excretion, respiration, reproduction, sensitivity towards touch, light, heat, etc. Non-living things do not have these characteristics. Sunflower turns its face towards the sun always. Mimosa or touch-me-not, chui-mui plant leaves contract when touched. Characteristics of living things. Living organisms are made up of cells and they have a definite life cycle. Some plants and animals are unicellular like bacteria, yeast, amoeba, and some are multicellular such as human. But the life of both begins from a single cell. Did you know? A newborn baby has more than 2,000 million cells. Living things grow. Living things usually grow. Growth occurs within the body by the division of cells. Examples are growth of a plant and man, etc. In non-living things, growth occurs due to addition of material on the outside. For example, a sand heap grows due to addition of sand. Living things move. All living things move in search of food, shelter, and water. Plants also move towards light and water. Living things reproduce. All living things reproduce. They give birth to young ones like themselves. If living things do not reproduce, there would be no life after some time on the earth. Living things respond to stimulus. If you accidentally touch a hot utensil, you quickly withdraw your hand. This is a response. The cause of response is called the stimulus, which in this case is the hot utensil. Similarly, leaves of mimosa plants droop if something touches it. The response of a plant to light is known as phototrophism, and the response of roots towards gravity is called geotrophism. Living things need food. All living things need food. Plants called autotrophs prepare their own food, and the animals called heterotrophs depend on plants and other plant-eating animals for food. Living things excrete. It is the process by which living organisms expel waste from the body. Animals intake oxygen and give out carbon dioxide as waste while breathing. Animals also expel food waste after digestion. Plant intake carbon dioxide through stoma. Living things respire. All animals breathe and intake oxygen. This oxygen combines with the food and gives energy to day-to-day activities. Living things have a definite lifespan. All living things die after a certain period. The time period that an organism lives is called its lifespan. Lifespan of animals varies from a few minutes to several years. Table showing organisms with average lifespan. Organisms: butterfly, average lifespan 20 minutes. Housefly 1 to 4 months. Mouse 2 to 3 years. Squirrel 8 to 9 years. Dog 15 to 18 years. Lobster 20 years. Lion 20 to 25 years. Horse 25 to 30 years. Ostrich 45 to 50 years. Man 60 to 80 years. Elephant 70 to 90 years. Tortoise 120 to 150 years. Bristol corn pine thousands of years. Species: various organisms differ from each other. Difference may be very slight. They may look similar. For example, dog, cat, pig, and goat look similar but differ slightly. A group of similar living organisms which have similar body parts live in the same habitat, eat the same kind of food, and reproduce among themselves is known as species. Table of Chapter 8. The Living Habitat. Introduction. Fish live in water. Cactus plant grows in deserts. Wild animals live in forests where they get food. So all living things live in several places and they become used to the conditions prevailing there. Habitat. Habitat is a place where an organism lives comfortably, which provides it food, protection from enemies, and conditions to breed and survive. Habitat is more specific than environment. A freshwater fish cannot survive in seawater, though both require water to live. The same is true to other organisms. Importance of habitats. A good habitat provides its inhabitants the following. 1. Suitable place to stay, rest and feed. 2. Provides protection suitable for breeding and rearing of their offspring. Type of habitats. Habitats can be grouped into 3 categories. Number 1. Terrestrial. 2. Aquatic. 3. Aerial or arboreal. Number 1. Terrestrial. It means living on land, climate, temperature, etc. influence it. 2. Aquatic. Aquatic habitat includes water. Fish is an aquatic animal. 3. Aerial. Aerial habitat includes air. Animals living on trees are known as arboreal. Factors influencing the habitat. Several factors influence the habitat of an organism. They are: number 1. Temperature. 2. Light. 3. Water. 4. Air. 5. Soil. Temperature. Some plants and animals grow well in warm places and some in cold places. Polar bears and penguins are found in cold places. Tigers, elephant live in warm jungles. Cow can bear heat, but a buffalo cannot. A camel can tolerate the high temperatures of the desert. Temperature is the measure of hotness or coldness. Light. Green plants need light to make food and to grow. Animals like earthworms, centipedes, millipedes do not like night. Distribution of aquatic plants and animals depends on the amount of light reaching the different depth of the water. Water. All living organisms need water for their survival. Water covers 71% of Earth's surface. Cacti and camels can live in dry places. They store water in their special organs. Air. Animals and plants require oxygen and carbon dioxide to respire and to make food. The cycling of oxygen and carbon dioxide between biotic components is essential to keep their balance in nature. Concentration of carbon dioxide causes warming of the earth, global warming. It is very serious for the existence of life on earth. We need more and more plants to grow to stop global warming. Winds also disperse seeds and pollinate flowers. Soil. Soil is essential for the existence of plants. Soil provides water and nutrients to the plants. Organisms like earthworms, bacteria, insects, and burrowing mammals live inside it. Did you know? Earthworms feed on soil which contains dead and decaying organic matter. Adaptations. The development of characteristics which help an organism to survive in a particular environment is known as adaptation. These characteristics are shape, size, structure, color, behavior, etc. Degree of adaptation differs in different groups of plants and animals. Fish is adapted to aquatic life. Man shows generalized adaptations. He can adjust himself to diverse habitats. Adaptations in plants and animals. For survival and existence, all living organisms need to be well adjusted to their habitat. They develop the properties to survive over a period of time. Different habitats lead to the development of different kinds of adaptive features in living organisms. Habitat adaptations in plants. On the basis of habitats, plants are divided into three groups. A. Xerophytes. B. Hydrophytes. C. Mesophytes. Xerophytes. Plants that grow in scarcity of water, that is, in desert or in very dry places. Common xerophytes are cactus, agave, yucca, etc. Xerophytes show the following adaptations. Number 1. Their root system goes deep in the soil for water. 2. Leaves are modified into spines as cactus. 3. Leaves are coated with cuticle to check loss of water. 4. Stems become thick and fleshy to conserve water as in cactus. Hydrophytes. These plants grow in watery place. Common hydrophytes are Hydrilla, Pistia, Lotus, etc. Hydrophytic adaptations are as: Number 1. They have poorly developed root system. 2. Leaves are mostly thin and ribbon-like. 3. Tissues usually have air spaces to keep the plant afloat. Mesophytes. These plants grow around us. Most of cultivated plants belong to this category. Some common mesotypes are apple, neem, guava, orange, etc. Mesophytes show the following adaptations. Number 1. They have well-developed roots with hairs. 2. Stem is solid and branched. 3. Leaves are of various sizes and shapes. Modification in plants for specialized functions. In plants, some of their parts perform special functions as potato and ginger plants store food in the stem. Potato, sugarcane plants, stem and leaves serve as means of vegetative propagation. In lemon plant, auxiliary buds are modified into thorns to protect the plant from grazing animals. Habitat adaptations in animals. There are 4 types of habitat adaptations in animals. Number 1. Terrestrial. 2. Aquatic. 3. Amphibious. 4. Aerial or volant. Terrestrial adaptations. Animals which live on land are called terrestrial animals. Conditions of weather are not the same everywhere. So, these animals develop adaptive features as per their habitat. Some common terrestrial animals are dog, lizard, snake, camel, etc. The adaptive feature of this group are have lungs, respiration, body covered with scales or hair, well-developed nervous system, and they move on their feet and limbs. Aquatic adaptations. Animals which live in water are known as aquatic animals. Some of them are fish, whale, octopus, etc. They have following adaptations: streamlined body, tail and fins for swimming, gills for respiration, body with covering like cuticle, waxy coating to prevent rotting and decay. Amphibious adaptations. Animals which can live both on land and in water are called amphibians. Some of them are frogs, toads, etc. They have the following adaptations: moist skin which helps in respiration, respire through lungs also, strong and webbed feet for hopping. Chapter 9. Plants. Form and functions. Introduction. Plants can be seen everywhere Life is impossible without plants. Plants differ in size and shape. Some are small while others are big. Plants provide us almost everything to live. Some plants grow very big and have hard and woody stems. Some grow small and have soft stems. Types of plants. Plants can be divided into herbs, shrubs, and trees. Plants like coriander and grass have short, thin, soft, and green stems. They are called herbs. Plants like rose and hibiscus have a thin but hard stem. They are called shrubs. Some plants have a tall, hard, and strong stem are called trees. Some plants grow along the ground. They are called creepers. Some take the support of others and climb on them. They are called climbers. Plant systems. Different parts of plants perform different functions to keep it alive. Some of them are the root systems. The root and its branches make up the root system. Characteristics of a root. The root is underground, non-green part. It grows into the soil away from sunlight. A typical root consists of primary roots and secondary roots. Every root has a cluster of very fine thread, like root hairs, to absorb water and minerals from the soil. Types of root system. Root system is of two types. Number 1, taproot system. 2, fibrous root system. Number 1, taproot system. It consists of a single main primary root with lateral branches. The primary root grows vertically downwards in the soil. It is found in plants like castor, pea, mango, and gram. Number 2, fibrous root system. In this system, primary root is replaced by a cluster of thin fiber-like roots. These are called fibrous roots. Plants of wheat, maize, rice, barley have these roots. Modification of roots. Roots have adapted to various conditions. 3 types of root modifications are: Number 1, storage roots. The tap roots of plants like carrot, turnip, and radish are swollen and fleshy to store food. Number 2, supporting roots. In maize and sugarcane plants, except from fibrous roots, other roots develop from the lower nodes of the stem. They grow downwards and support the plant. These roots are called still roots. In the banyan tree, supporting roots arise from the horizontal branches and go into the soil and act as pillars. These pillars-like roots are called prop roots. Number 3, nodulated roots. Pea, bean, groundnut, and mung plants possess nodulated roots. These plants are called leguminous plant. Functions of roots. A root fixes a plant firmly. It absorbs water and minerals. It transports absorbed water and minerals up to the stem and branches. It checks the soil erosion. The shoot system. It forms the aerial portion of a plant. It consists of: Number 1, main stem. 2, leaves. 3, buds. 4, branches. 5, flowers. 6, fruits. 7, seeds. A detail of each above is as the stem. It is the aerial part on which buds, leaves, flowers, and fruits are born. It grows towards the sunlight. The leaves grow on the stem at definite points called nodes. Between the 2 nodes, the part of the stem is called internode. Modification of stem. There are a few modifications of stem to be taught to you at this stage. They are: Number 1, storage of food. Stems of some plants become thick and fleshy due to storage of food. Potato, Colocasia are some stems which store food. Number 2, mechanical support. In some plants, like grapevine, the auxiliary buds are modified into thin, wiry, coiled structures known as tendrils. Tendrils help the plant to climb the neighboring support. Root. Number 1, The root is descending non-green portion of the axis of the plant. It grows towards the soil and water and away from the sunlight. Stem. Number 1. The stem is an ascending portion of the axis of the plant. It grows away from the soil and water but towards sunlight. Number 2. Root. It is not differentiated into nodes and internodes. Stem. Number 2. It is differentiated into nodes and internodes. Root. Number 3. The root has rootlets and root hair and does not bear leaves, buds and flowers. Stem. Number 3. The stem bears leaves, buds and flowers. Number 3. Food manufacturing. In some plants, stem carries out the process of photosynthesis. These plants grow in the deserts or in very dry places. Cactus is a typical example. Functions of stem. It supports branches, leaves, flowers, fruits and buds. It helps in transportation of minerals and water absorbed by roots to the other parts of the tree. It stores food as in the case of potato, onion, garlic, etc. In some plants, stems get modified as tendrils which help in climbing. The bud. A bud is a condensed shoot. Some buds grow into new shoots called vegetative buds, and some grow into flowers are called floral buds. The leaf. The leaf is a flattened, thin, green, lateral structure borne on the stem. Leaf is attached on the stem at a node. It has stalk called petiole and a pair of very small leaves at the base called the stipulus. Broad expanded part of a leaf is called leaf blade or lamina. It has thick midrib, thin veins branch out from this midrib. Veins are further divided to form a fine network of veinlets. Veins transport food and water. Types of leaves. Plants have Chapter 10. Body movements. Introduction. Movement is an important feature of living things. You also have to move your fingers to do work. Your eyes blink. Your body parts move when you walk, run, jump or skip. Table showing movements of some common animals. Serial number 1. Name of the animal: buffalo. Body part used during movement: legs. Type of movement known as walking. Number 2. Name of the animal: fish. Body part used during movement: fins. Type of movement known as swimming. Number 3. Name of the animal: bird. Body part used during movement: wings. Type of movement known as flying. Number 4. Name of the animal: snake. Body part used during movement: muscles. Type of movement known as slithering. Number 5. Name of the animal: human being. Body part used during movement: bones, muscles. Type of movement known as walking. Number 6. Name of the animal: kangaroo. Body part used during movement: legs. Type of movement known as hopping. Human body and its movements. Some parts of your body can move in different directions, some in one direction only, and some parts you cannot move at all. Joints. The places where two body parts seem to be joined together are called joints. Examples: shoulder, elbow or neck, etc. There are different kinds of joints in our body. They are ball and socket joint. In this joint, one bone like a round ball fits into another bone which is like a socket. This joint allows movement in all directions. They are found in shoulders and hip girdles. Hinge joints. This joint allows the bones to move in one direction only. It is like a hinge fixed to a door or window. Hinge joints are found at elbows, knees, fingers and toes. Pivot joints. In this joint, one cylindrical bone rotates in a ring of other bones. This joint is between the head and the neck. It allows us to bend our head forward, backward, and turn it to left or right. Gliding joints. In this joint, one bone glides over the other. Gliding joints are found in the wrists and ankles. They allow limited movements. The human skeleton. The human skeleton is made up of bones. Bones protect internal organs. They also make red blood cells and store calcium. There are 206 bones in the body of an adult. Bigger bone in femur or thigh bone. The smallest bone is stirrup or stapes in the middle ear. Did you know the marrow inside a bone can make up to 5 million red blood cells every day? When you were born, you had about 250 bones, but by the time you finish growing, you will have just 206 bones. Bones are divided into 5 groups. Number 1. Skull. The bones of our head make the skull. Skull has 22 bones. Skull protects our brain. Lower jaw bone is the movable bone. Number 2. Backbone. The backbone or spine is made up of 33 vertebrates. It is slightly S-shaped. It is the main axis of our body. It protects the spinal cord. Backbone gives elasticity to our body to bend forward, backward, right or left. Number 3. Ribs. Chest bones are called ribs. There are 12 pairs of ribs out of 10 pairs join chest bone and the backbone to form a box called rib cage. It protects our heart and lungs. The last 2 pairs are not joined with any bones, thus called floating ribs. Number 4. Limbs. We have 2 pairs of limbs, forelimbs, arms, and hind limbs, legs. There are 26 bones in each of our arm and legs. Each arm has 3 big bones: humerus, radius, and ulna. Humerus is the bone of upper part of the arm, while radius and ulna are the bones of lower part of the arm. The palm and the fingers have many small bones. Each leg has 3 bones: femur, tibia, and fibula. Femur or thigh bone is the biggest bone in our body. Tibia and fibula are the bones of the lower part of the leg. Number 5. Girdles. There are 2 pairs of girdles, a pair of shoulder girdle and a pair of hip girdle. The hip girdles, also called pelvic girdles, are strong bones. They support the weight of the upper part of the body. Muscles. Muscles are responsible for all our body movements. Muscles are attached to the bones. Muscles always work in pair. The most attractive muscle in the body is the eye muscle. Muscles can be grouped as voluntary and involuntary muscles. The muscles whose movements are under our control are called voluntary muscles. For example, movement of our hands and legs. The muscles whose movements are beyond our control are called involuntary muscles. Example, muscles of our heart, eyes, stomach, and intestines. Heart is made up of very special muscles called cardiac muscles, which start working from the birth till the death. Did you know your body's longest muscle is Chapter 11. Motion and measurement of distance. You move from one place to another on foot or by using various machines like bicycle, scooter, car, bus, and aeroplane depending on the distance to travel. Moving from one place to another is called transportation. History of transportation. Early man moved on foot. He used wooden plank to travel on water. After the invention of wheel, He used carts, etc. pulled by animals. In 19th century, steam engines revolutionized transportation. Modern engines using petrol, diesel, CNG, electricity, etc. has made transportation very fast. What is motion? Everything in the physical world is in motion, from the tiniest particles within an atom to the largest galaxies of stars. A famous scientist says, "You see many things around you moving, one walking along a road, moving cars, flying birds and aeroplanes, etc. are examples of motion." Rest and motion. A body is said to be at rest when it does not change its position with respect to any fixed point in its surroundings. But in this universe, however, there is no fixed point. Hence, there is nothing at absolute rest. Rest and motion are relative terms. Suppose you are traveling in a train. For co-passengers, you are at rest, but for a passerby, you are in motion. As your train is moving, the continuous change of position of a body with respect to another is called motion. Different types of moving objects. Number 1. On land, car, bus, truck, etc. Number 2. In air, aeroplanes, birds, etc. 3. In water, fish and other aquatic animals. 4. In space, moon and stars. Uniform and non-uniform motion. When a body covers equal distances in equal intervals of time, the motion is said to be uniform, and when a body covers unequal distances in equal intervals of time, the motion is non-uniform. Types of motion. Any moving object may be in translatory, rotatory or oscillatory motion. Same time the motion is translatory. Moving bus or train, flying aeroplanes are some examples. Translatory motion is one of two kinds: rectilinear and curvilinear motion. When a body moves along a straight line, it is rectilinear motion, but when it moves along a curved line, it is curvilinear motion. Number 2, rotatory or circulatory motion. In this motion, a body moves about a fixed axis without changing its position. Some examples are spinning top, pirki, spinning wheel, fan, etc. However, while a drill is made by a drill bit, the drill bit is both in rotatory and translatory motion. Number 3, oscillatory motion. Oscillatory motion is that in which a body moves to and from about its main position. Swing of pendulum of a clock is in oscillatory motion. Periodic motion. When a motion repeats itself after a certain fixed period of time is called periodic motion. For example, Earth rotates about its axis in 24 hours and revolves around the Sun in 365 and 1/4 days and repeats it again and again. Non-periodic motion. Motion that is repetitive but not at regular intervals is non-periodic. For example, when a football player sometimes runs fast and sometimes slow in the field is non-periodic motion. Random motion. When a moving object does not take a fixed path and keeps on changing its direction is called in random motion. Motion of a bird flying in the sky in random motion. What is measurement? The process of comparison of an unknown quantity with a known quantity is called measurement. Earlier methods of measurement. Early man used his body parts for measurement of length. Some units were yard, inch, cubit, and foot. Did you know? We have now invented techniques that enable us to measure distances that are much smaller than 1/1,000,000th part of a meter. These highly precise techniques have played a big role in improving our understanding of the world of atoms and their very tiny constituents. Standard units. A standard Chapter 12: Electric Current and Circuits. Introduction. Electricity is one of the most useful forms of energy. It is used to run fans, television, radio, refrigerator, computer, etc. We get electricity from a power station. When it is not available and it is dark, we look for a torch. Let us know how torch works. Torch. It is used in the night or if it is dark. There are two cells which pass electric current through the torch bulb, which in turn glows and produces light. First torch cell was made by two Italian scientists, Galvani and Volta. The voltaic cell. It was invented by Volta. It has rods of zinc and copper placed in a solution of dilute sulfuric acid. When rods are connected by a wire, electric current flows. The dry cell. It is an improved voltaic cell. No liquid is used inside it, so it is called dry cell. It was improved by an engineer, George Lactanche, in 1866. Chemicals inside the cells produce electricity. An electric cell has two terminals, positive at the metal cap and the negative at the bottom metal disc. If both terminals are connected, electric current flows. Button cell. It is a small button-sized dry cell. It is used in electronic devices such as wristwatches, calculators, etc. Solar cell. This cell converts solar energy directly into electrical energy. Solar cells give power to street lights and water pumps in remote places where electricity is not available. Electric bulb. The bulb is made out of a thin clear glass. Inside the bulb, there is a thin wire filament of tungsten metal. It can withstand very high temperatures. Filament is supported by two thick wires. One is attached to the lower side and the other to the bottom of the bulb. These wires are two terminals of the bulb. Bulb has partial vacuum and filled with argon gas. When electricity flows through the filament, it becomes extremely hot and produces heat and light. If, however, filament breaks up, bulb is said to have fused. Electric current. Modern life cannot do without electricity. Electricity flowing through wires is called electric current. Its SI unit is ampere. Electric circuit. The path through which electricity flows from its source to the electric appliance is called electric circuit. How is the circuit formed in this case? Refer to situation B. The bulb has two terminals, one at the base and other at the side of bulb. The terminal at the base is connected to the positive terminal of the cell and other is connected to the negative terminal of the cell through wires called loop of wires. This loop of wires with source and appliance is called a circuit. If the circuit is complete, current flows, otherwise not. Did you know? Why don't we get a shock when we touch a cell? The cell that is used in clocks, calculators, watches, mobile phones does not cause a shock because the electric current in the circuit is weak. However, car batteries are powerful and can give a shock. Switch. Switch is a device which is used to on or off the circuit. All electric appliances have a switch. May be of different types, but they work on the same principle. When the switch is on, circuit is complete, and when it is in off position, the circuit is incomplete. Conductors and insulators. Materials which allow electric current to pass through them are called conductors, and which do not allow to pass are called insulators. Table of conductors and insulators. Conductors: iron, gold, silver, copper, aluminium, moist air, acids, tap water, human body. Insulators: cotton, wool, rubber, plastics, paper, glass, pure water, leather, air. Power saving tips. Switch off lights, fans, and other electrical gadgets when not in use. Sunlight is available free of cost. Make maximum use of daylight and reduce the use of artificial light. Keep bulbs and tubes clean to get better light. Use CFLs or LEDs and energy-saving bulbs in place of filament lights. They last longer, give out more light, and consume less electricity. Do not open the door of your refrigerator too often. Use low-voltage bulbs of CFLs for corridors and other less important areas. Remove the cord of the appliance from the supply when not in use. Use copper wires for electric connection. Activity. Chapter 13. Magnets. Introduction. In a pin holder, pins seem to be sticking to the holder. That is due to the magnet inside the holder, which attracts iron pins. Magnets are used in many devices such as doorbells, televisions, computers, telephones, and electric motors. Let us know about the magnets. Discovery of magnets. Around 800 BC, a mineral, magnetite, was discovered. It attracted iron objects. It was also noticed that a thin strip of magnetite rotates freely. It aligned itself in the same position. For this property, it was called leading stone or lodestone. Did you know? It is believed that the direction-finding property of an iron rock found in Magnesia was first studied by the Chinese. The Chinese sailors used to keep a piece of this rock on a wooden cross or on a piece of cork, floating on the water present in a bowl. One end of this rock always pointed towards north. This helped them in finding the direction, especially when the sun or the pole star was not visible. Shapes of magnets. Magnets may be cylindrical, bar-shaped, or horseshoe. They may be needle-like according to their use. Different types of man-made magnets. Today, different types of magnets are being made from different materials of different shapes, fit for the purpose of use. The pole of a magnet. Every magnet has two poles, north and south. One end of a magnet is north pole and the other is south pole. Properties of a magnet. If a magnet is suspended freely, it always remains in the north-south direction, north pole to the north and south pole to the south. This property is used to make a compass which helps to detect the direction. Sailors use this device. Like poles of magnet repel and unlike poles attract each other. If two magnets are brought close to each other, their like poles will repel, while unlike poles will attract each other. The magnetic strength of a magnet is concentrated at its ends or poles. Two poles of a magnet cannot be separated. The poles of a permanent magnet cannot be separated just by cutting a magnet into pieces. If a magnet is cut into pieces, each piece becomes a separate magnet with north-south poles at the ends. Each magnet has a magnetic force which can pass through non-magnetic objects such as paper, plastic, or wood, making an artificial magnet. Several methods are used to make artificial magnets. Some of them are: number 1, single touch method using single magnet. Number 2, single touch method using 3 magnets. Number 3, divided touch method using 4 magnets. Number 1, single touch method, single magnet. In this method, piece to be magnetized is put on the table. It is stroked by one pole of a bar magnet in one direction only. On reaching the end, magnet is lifted and again same procedure is repeated. Number 2. Single touch method. 3 magnets. One end of iron piece to be magnetized is put on the S pole and the other on the N pole of 2 bar magnets and is stroked with one pole of a third magnet. This pole must be opposite to that lying under the start end of the iron piece. Divided touch method. 4 magnets. 2 magnets are placed on the table with their opposite poles towards each other. Iron piece is put over these 2 magnets. Then, the other 2 magnets are put at the center of iron piece with their opposite poles together and are moved towards its opposite edges. Each magnet is moved along the bar in one direction only. Taking care of magnets. Proper care of magnets is to be taken or they may lose their magnetism. Careless knocking around, beating with a hammer or heating on a flame may destroy their magnetism. Magnets can be protected by keeping them on magnetic keepers. Uses of magnets. Number 1. A compass is used to know the direction. Number 2. Magnets are used in toys, tape recorder, telephone, doorbells, etc. Number 3. In industries, large electromagnets are used to separate metals like iron, steel, cobalt, and nickel from the scrap. Activity. Chapter 14. Rain and Water Cycle. Introduction. Natural phenomena are cyclic. The sun rises in the east and sets in the west every day. Seasons are cyclic. They occur at regular intervals. This happens due to cyclic motion of the earth. Interchangeability of 3 states of matter. Water exists in 3 forms. Solid as ice below 0 degrees Celsius, liquid as liquid between 0 degrees Celsius to 100 degrees Celsius, and gas as vapors, steam, above 100 degrees Celsius. Ice solid changes to water liquid when heated, and on further heating, water liquid changes to steam or gas. This process is interchangeable. Thus, water exists at all places, maybe in small quantities, on the earth and makes life possible. Water table. Water which fills spaces below the surface of the ground is called underground water. The surface of the underground water, that is, the surface below which the pores of a rock are filled with water, is called water table. The water in the seas and ocean is saline. We cannot directly use it, but this water plays an important role in the water cycle. The water cycle. Number 1. Disappearance of water. The sun's heat continuously evaporates water of water bodies. Water vapors rise up and accumulate in the air. Number 2. Loss of water by plants. Plants release excess water absorbed by roots through the stomata on the leaves. This process is called transpiration. Formation of clouds. When water vapors are cooled, they change to liquid water. It is called condensation. When water vapor reaches a certain height in the atmosphere, it gets cooled and condenses to form tiny droplets of water. These tiny droplets float in the air, appear to us as clouds. When the clouds becomes heavy, they fall on the earth as rain. Somewhere, clouds may also fall as snow or hail. Going of water as vapor into air by evaporation and transpiration, formation of clouds by condensation, and coming back to the earth as rain, snow or hail is called the water cycle. This continuous process maintains the water supply on land. Evaporation and condensation also play an important role in the formation of the following features. Dew. On a very cold day, water vapors in the air condense to form shining drops called the dew. It can be seen on leaves, flowers, and grasses. Frost. When air comes in contact with something extremely cold, the water vapor freezes to form tiny ice crystals called frost. It can be seen sometimes on the window panes of your house and car. Fog. When water vapor in the air condenses to form clouds on dust particles just above the ground, it is called fog. Snow. In the high mountains, water vapor in the air condenses directly into ice crystals instead of water drops. This is known as snow. Hailstones. When ice crystals pass through very cold region, they join to form big balls. They fall to the ground as hailstones. Hailstones can cause great damage to crops. Drought and floods. Drought. If a certain region on the earth does not get adequate rainfall in successive years, there occurs an extreme shortage of water called drought. Crops cannot be grown, so a shortage of food occurs, resulting in acute malnutrition and even death due to starvation. Floods. Excessive rainfall, which cannot be accommodated into the water bodies, is called floods. Floods can cause grave situations. Crops are destroyed. There is a great loss of life and property. Drinking water becomes polluted. This may result in epidemic diseases. Did you know? The 2005 Maharashtra floods refer to the flooding of many parts of the Indian state of Maharashtra, including large areas of the metropolis Mumbai, a city located on the coastal of Arabian Sea on the western coast of India, in which at least 5,000 people died. It occurred just 1 month after the June 2005 Gujarat floods. The term 26th July now is in context always used for the day when the city of Mumbai came to a standstill. Activity to demonstrate free. Chapter 15. Light. Introduction. Light is a form of energy. It enables us to see. It is essential for life. The objects that produce light are called luminous objects, and those that do not are called non-luminous objects. Natural sources of light. The sun is the chief natural source of light on the earth. Besides the sun, stars, however, very far are also the natural source of light. Some insects, as glowworm and aquatic animals, also produce natural light. Artificial or man-made sources of light. An electric lamp, a burning candle, a kerosene lamp are some common artificial sources of light. Hot and cold sources of light. Large number of artificial sources of light are hot when they produce light. Examples are burning candle, kerosene lamp, electric bulb, the sun, etc. Glowworm is the natural cold source of light. A fluorescent tube is only moderate hot. Light, a form of energy. Light is neither a solid, liquid or gas. It is a form of energy. This energy varies with the power of the source. Sunlight has a huge amount of energy. Sunlight is mainly responsible for the life on the earth. Speed of light. Speed of light is approximately 300,000 kilometers per second. Sunlight takes about 8 minutes to reach the earth. Long distances in space are measured in light years. A light year is the distance traveled by the light in 1 year. Rays and beam. Light travels in the form of rays, which is represented by a line with an arrow. A beam is made of several rays. The rays in a beam can be parallel, divergent, or convergent. Light travels in air mostly as parallel beams. However, with the use of lens, it can be made divergent or convergent. Opaque, translucent, and transparent materials. An object through which light can pass is called opaque material. Materials such as wood, stone, and metals are opaque material. An object which allows some amount of light to pass is called translucent. Certain types of plastics and glasses are translucent. An object which allows light to pass through it completely is called transparent. Objects made of clear glass and plastic are transparent. Shadow. An opaque object blocks light falling on it. Hence, a dark patch is seen on the other side of the object. It is called shadow. When the source of light is quite bigger than the object, the shadow has two distinct parts. The dark part called umbra and the greyish part receiving some rays of light called penumbra. Facts about shadows. The shape of the shadow depends on the shape of object, position of source of light. Shadow gives no detail of the object. It just gives the shape. A screen is necessary to obtain a shadow. Eclipses. The earth and the moon both are opaque, hence produce shadow. When the shadow of one thing falls on the other, eclipse occurs. Lunar eclipse. At certain times, earth comes between sun and the moon. The shadow of the earth falls on the moon and moon is partially seen or not seen. This is called lunar eclipse. Solar eclipse. Sometimes the moon comes between the sun and the earth. The shadow of the moon covers the earth partially or fully, causing partial or full solar eclipse. Did you know? We should not see a solar eclipse with naked eyes because it may damage our eyes permanently. Safety glasses are available to view the eclipse. It can also be viewed through a smoked sheet of glass. Another method is to use the principle of a pinhole camera to form an image of the sun on a screen. If you have a video camera, point it towards the sun and record the image, or connect the camera to a TV and watch the image on the TV. How is an image in a mirror formed? A mirror has a smooth, polished surface and acts as opaque object. When a beam of light falls on a polished surface, rays get reflected. If the reflected rays are parallel to each other, a clear image is formed on the reflecting surface. If, however, reflected rays are not parallel, no image will be formed. For example, a rough floor scatters rays in all directions, so no image is formed. Pinhole camera. A pinhole camera forms a photograph like image of a bright object on the screen. For a pinhole camera, take a rectangular card box, remove its lid, paste a piece of tracing or wax paper in place of lid. Make a pinhole in the center of the side opposite to the tracing paper. Now, if you point the pinhole towards the object, its real inverted image will be seen on the tracing paper. Did you know? The moon can be seen because it reflects light from the sun. Light takes over 8 minutes to reach from the sun to the moon. Some of this light reflects from the moon's surface and reaches us on Earth in 1.3 seconds. Activity. Light. Chapter 16. Importance and conservation of water. Introduction. What is a prime natural resource essential for the survival of life? You use water every day for various purposes. It is not possible to do without water. Importance of water. A person can live for several weeks without food, but without water, he cannot survive for more than a few days. The bodies of all plants and animals have large amount of water. Water is responsible for many functions in the body, such as digestion, absorption of nutrients by the body, getting rid of waste and maintaining body temperature. In plants, it helps in germination of seeds, their growth, and in photosynthesis process. Hydroelectricity is produced with the help of water. We cook our food with water. Water is used in agriculture and industries. It is also used as medium for transport. Uses of water. Water is used for drinking, cooking food, bathing, and washing clothes. Water is used in processing and manufacturing cars, plastics, paints, fertilizers, chemicals, leather, cement, and fabrics. Electricity. Energy of flowing water is converted into electricity in hydroelectric power stations. Recreation. Nowadays, lakes, rivers are used for fishing, swimming, and boating activities. Several water amusement parks have also sprung up in big cities. Need for water conservation. Water, like air, is the most abundantly available substance on the earth. It covers more than 3/4 of the earth's surface. It also exists as snow and ice on mountains. Water is found within the earth's crust. It is also present in clouds as vapors. 97% of water available is in seas and oceans. 2% water is fresh water, which we can use. Water is a natural resource. Urbanization and industrialization are polluting water continuously. Drinking water is becoming scarce. We must take special precautions to consume and preserve water. Did you know? Bharat Ratna Sir M. Visvesvaraya, the father of modern Mysore state, now Karnataka, was responsible for the building of the very first electricity generation plant in Asia, Shivanasamudram, near Mysore in 1894. How to conserve water? Rainwater harvesting. It is a simple process of collecting and storing rainwater for future use. It can be harvested directly from rooftops of the buildings and collected into the underground tanks.
It can be allowed to go into percolation tanks,
from where it can seep into the ground and thus replenish the groundwater. Benefits of rainwater harvesting: increase in availability of water, rise in water level, improves the quality of groundwater, prevents soil erosion and flooding. Check dams. Check dams are structures built to stop rainwater from flowing away. It is collected at a place and slowly sweeps into the ground. Such water supplies fresh water to the lakes, ponds, and well into the region, which can be used for drinking and irrigation. Make water saving a habit. Do not let taps drip. Do not allow water to flow all the time while washing clothes or cleaning utensils. Use a bucket instead of a hose to clean cars and sideways. Water your plants in the morning to prevent evaporation. Use minimum amount of water while brushing and bathing. Do not throw away water used for washing vegetables, rice or dal. Use it to water plants. Keywords: fresh water, water which we can use, soil erosion, washing of the top layer of soil, condensation. Chapter 17. Air around us. Introduction. Air is all around us. It is the most essential substance to stay alive both for animals and plants. Moving air is called wind. Winds are used to sail boats in water and gliding in the air. Air conducts sound vibrations. Without air, we cannot hear. Composition of air. Air is a mixture of several gases like nitrogen, oxygen, carbon dioxide, argon, neon, water vapors, and dust particles. On an average, nitrogen is 78%, oxygen 21%, and the other gases are 1%. Properties of air. Air occupies space. Air occupies space. It is colorless and transparent. Since it occupies space, it is used to fill balloons, pillows, football bladders, tubes of vehicles, etc. Air has weight. Anything that occupies space also has weight. So, air also has weight. Air exerts pressure. Anything that has weight also exerts pressure. So, air exerts pressure in all directions. Atmosphere. The blanket of air surrounding the earth is called atmosphere. It extends up to 1000 km above the surface of the earth. As we go high, air becomes thinner and the volume of oxygen sharply decreases. Due to this, some people face difficulty in breathing. Respiration by organisms in different locations. Organisms living on land get their supply of oxygen directly from the air. But organisms living in water have no access to air. How do they respire? How do the organisms living in water respire? The water animals take dissolved oxygen with the help of their gills for respiration. How do the organisms living under soil respire? The organisms living under the soil, such as in the roots of a plant, respire by taking oxygen present in the soil. Organisms living in burrows and holes respire in the air which reaches to them through these holes. Uses of air. Number 1. It protects all living beings from harmful ultraviolet rays. Number 2. Compressed air is filled in the tires of the vehicles. Oxygen of air is consumed for respiration. Nitrogen is used to manufacture fertilizers. Number 4. Birds fly in the air. Moving wind is used for running windmills. Windmills are used to run flour mills and for generating electricity. Number 5. Air helps in sailing boats, in transmitting sound, and in the dispersion of seeds. Important constituents of air. Nitrogen. It is the most abundant. Chapter 18. Waste Management. Introduction. All human activities produce waste called garbage. This garbage is collected and carried by municipal vehicles to a distant place for disposal. It takes a lot of time for decomposition of this garbage. Waste. The new technologies have improved the living standards, but they have also resulted in large amounts of wastes. The waste materials are generated by household activities, industries, hospitals, vehicles, and natural processes. Types of wastes. Wastes can be grouped as biodegradable and non-biodegradable wastes. Biodegradable waste. Wastes that decay and mix with soil are called biodegradable, like food wastes, paper, clothes, woods, etc. Biodegradable waste breaks down naturally and make the soil more fertile. Biodegradable waste is called organic waste. Non-biodegradable waste. It does not rot and mix with the soil. It includes the objects made up of plastics, metal containers, and broken glass. How we can control waste? Minimize use. Although we cannot stop using things, we can reduce their usage. Use cloth bags in place of plastic bags. Reuse. One can use old and discarded material for another useful purpose. Old clothes can be used for making wall hangings, doormats, etc. Refuse. Refuse more consumption. More consumption means more produce of waste. Recycle. Waste material should be recycled to produce useful materials which can be used again. Recycling biodegradable waste. Composting. Organic waste is allowed to rot in a compost pit. The natural rotting yields the waste into nutrients or manure. This method is called composting. It is a cheap, clean and safe. Vermiculture. Compost can also be produced with the help of earthworm. This is known as vermiculture. Kitchen waste like vegetable and fruit peel can be used to make vermicompost. The earthworms, along with the microorganisms, decompose organic waste and convert into compost in 3 to 4 weeks. Biogas. It is produced from organic waste and is used as fuel. Bacteria decomposes the mixture of cow's or buffalo's dung, garbage, and crop waste to produce biogas. Biogas can be used to cook food and generate electricity. It does not pollute air. It is clean and cheap source of fuel. Benefits of biogas. The process of producing biogas kills many harmful organisms in the waste. Less refilling sites are needed due to waste used in producing biogas. Recycling paper. Used paper can be recycled. It will ensure cutting of lesser trees, thus saving forests. Did you know? Recycling of 1 million stake of newspapers saves the equivalent of 10 million pine trees. Making paper from scrap instead of wood pulp yields 50% savings of water and energy. Recycling metals, glass and plastic waste. Metal waste. Metal waste is heated, melted and used to make new products. Plastic waste. Plastic waste is melted and converted into pellets, which can be further used in the manufacture of household products. Waste glass. Waste glass is heated and melted. Melted glass is used to produce various new products. Waste disposal. Waste is generally collected by municipal authorities. This waste is a mixture of many things. It can be separated into 4 parts. Metal, plastic, and glass are separated and can be recycled. Organic waste is used to make compost. Paper, textile, and wood can be recycled to produce new paper or can be as fuel. Stones, mud, and soil is used in landfills. Landfilling. It involves placing waste underground and covering it with soil. Landfilling can cause environmental contamination. Landfilling produces methane gas, which can be used as fuel. But natural decomposition is a slow process. Methane mixes in the air and pollutes it. Incineration. It is the burning of waste in the limited supply of oxygen. It produces heat, which can be used for various purposes. Hospital waste is cleared by this process. Say no to plastic bags. Plastic is non-biodegradable. It pollutes soil, water, and air. Use of plastic should be minimized. A few steps are: do not store food materials in plastic bags. Do not burn plastic. Do not throw plastic bags here and there. Educate people not to use plastic. Keywords: waste, discarded and unwanted.
Summative assessment. 2.
Fill in the blanks.